Hello students, so today we are going to learn the basic three trigonometrical identities. Sin square theta plus cos square theta equals 1 plus tan square theta equals sec square theta, and 1 plus cot square theta equals cosec square theta. These are the very basic trigonometrical identities which you will be using in the proofs of many questions, and you will use these in other mathematics and science problems also. So let us see from where these trigonometrical identities come. So let's start with a right angle triangle. I will make here. And let's say this is triangle, right angle triangle ABC, which is right angled at point B, and angle C we say that is angle theta. Okay, so in this right angle triangle, the side AB, that is known as perpendicular, the side BC, that is known as base, and the side AC, that is known as hypotenuse. And I think you all know also this Pythagoras theorem. You all know Pythagoras theorem. Pythagoras theorem states that in a right angle triangle, the hypotenuse square is equal to the sum of perpendicular square and base square. So this theorem we will be using in the proof of these three trigonometrical identities. So let's start with the first identity, sin square theta plus cos square theta equals 1. Let's start with the left hand side of the identity. Okay, I would also like to tell you what is the basic difference between an identity and an equation. An equation is true only for certain particular values of the variable. That is not true for all the values of the variable. But an identity is true for all the possible values of the variable. That's the basic difference of trigonometrical identity and trigonometrical equation. Rather, it is true for all the types of equation and identities. So an equation is true for only certain number of solutions, but an identity is true for all the values of the variable. So trigonometrical equation or any equation has only certain number of solutions, but an identity has infinite number of solutions. In a short way, you can say. Okay, so let's start with the left hand side of this identity, that is sin square theta plus cos square theta. And let's put the values of this sin theta and cos theta from this right angle triangle. Sin theta, as you know the basic definition, sin theta is defined as the ratio of perpendicular to the hypotenuse. So it is P upon H and square of this, plus cos square theta is base upon hypotenuse and square of this. So you can open the squares. It is P square upon H square plus B square upon H square, and it will become, you can take H square as LCM, and in numerator it will be P square plus B square. And from Pythagoras theorem you can write P square plus B square is equal to H square, as I have written here. So it becomes H square divided by H square, so it is 1, and it was your right hand side. So we proved that left hand side is equal to right hand side, or we can say that sin square theta plus cos square theta is equal to 1. So we proved the first identity. Now let's come to the second identity and third. So second and third identities, they can be proved with the help of first identity only. So let's write the first identity we just proved, sin square theta plus cos square theta is equal to 1. Let's divide each of these term by cos square theta. So you can write the first term will become sin square theta. So it implies that sin square theta upon cos square theta plus cos square theta divided by cos square theta is equal to 1 upon cos square theta. So from here we can write sin theta, this can be written as, first term can be written as sin theta upon cos theta whole square, and sin theta upon cos theta is tan theta. So it is tan square theta plus cos square theta upon cos square theta will become 1, and this is equal to 1 upon cos, that is also can be written as sec theta, so it will become sec square theta. So this was our second identity. 1 plus tan square theta is equal to sec square theta, or sec square theta is equal to tan square theta plus 1. Now let's come to the third identity, which is 1 plus cot square theta equal to cosec square theta. This also we can start with the first identity we proved, that was sin square theta plus cos square theta is equal to 1. Now we will divide each term by sin square theta here. So it will be sin square theta divided by sin square theta plus cos square theta divided by sin square theta, and this is equal to 1 divided by sin square theta. Now what we can write here, sin square theta upon sin square theta will become 1 plus cos square theta upon sin square theta, that can be written as cos upon sin, cos theta upon sin theta whole square, and cos theta upon sin theta is defined as cot theta. So it will become cot theta whole square, or you can write cot square theta, and this is equal to 1 upon sin square theta or 1 upon sin theta whole square, that it can be written as cosec theta square. So it will be cosec square theta. So this becomes your third identity which we had to prove. So this way we see that all the three identities we proved with the help of Pythagoras theorem. So that's all what I wanted to discuss with you. Thank you very much. Take care and bye bye.